So we're going to do a quick introduction to the unit circle, which is a useful tool when you're doing trigonometry. The unit circle is a circle of radius 1 centered at the origin. So that looks like this, and it can be described by the equation x squared plus y squared equals 1, because 1 is the radius, and the center is the origin, which is 0, 0. At this point, you might be thinking, wait a minute, this is a circle and trigonometry is about right triangles. How are we going to get right triangles out of this circle? If we pick any point on the circle, xy, we can draw a radius to that point and then draw a perpendicular line from that point to the x-axis. And now here we are with a lovely right triangle. And the side lengths in this right triangle, you've got the horizontal leg is x, the vertical leg is y. Those are the same x and y as you have in the coordinates of the point. And the hypotenuse is 1 because it's a radius of the circle. And we're going to go ahead and name the angle between the positive x-axis and the hypotenuse theta, which is that funny little symbol there. It's a Greek letter. It's a common convention in math to use Greek letters to name our angles because the Greeks did a lot of geometry stuff. So we're using theta because that's a common one. And it's also a convention in math that you measure angles in the unit circle going counterclockwise from the positive x-axis. So that's why we've put theta where we've put it here. And then if we wanted to start doing some trig, you might remember SOHCAHTOA. So the sine of theta is the opposite side over the hypotenuse, which is y over 1, which means that when you're working in the unit circle, the sine of theta is just that y coordinate in the point that you're looking at. Cosine is adjacent over hypotenuse, which in this triangle is x over 1, which means that when you're working in the unit circle, the cosine of any angle theta is the x coordinate of that point that you're looking at. And then tangent is opposite over adjacent, which is y over x, which means that in the unit circle, the tangent of your angle theta is the y over x for the point that you're looking at, and it's also the sine of your angle theta over the cosine of your angle theta. That's actually always true regardless of whether you're in the unit circle or not. So once again, that means that when you're working in the unit circle, you can measure an angle theta going counterclockwise from the positive x-axis, and that xy point where the ray for the angle intersects the circle gives you the cosine and the sine of that angle. So for example, if we just start with an angle of 0 degrees, the point for that is 1, 0. That means that the cosine of 0 degrees is 1 and the sine of 0 degrees is 0. We could go up 90 degrees. That point is 0, 1. The cosine of 90 degrees is 0. The sine of 90 degrees is 1. We could go out to 180 degrees, and we would see that the cosine of 180 degrees is negative 1, and the sine of 180 degrees is 0. We can go all the way to 270 degrees, see that the cosine of 270 degrees is 0, and the sine of 270 degrees is negative 1. If we wanted to go to 360 degrees, we would be back at the same place that we were when we had 0 degrees, and so on. We're going to do a little bit more in the next video, talking about more interesting angles in quadrant 1 specifically, but this has been a quick overview of how we can use the unit circle and SOHCAHTOA in order to find the sines and the cosines of angles. And you'll notice here that we can go beyond 90 degrees, as big an angle as we want, even though you couldn't draw a right triangle with an angle of 270 degrees. Because we have these definitions in the unit circle, we're still able to find the sine and the cosine of angles that big.